Welcome to episode 9 of China AI, where we have AI conversations brewed in Africa and look to make AI practical one conversation at a time. I'm your host, Stephen Google, and today I'm really looking forward to the conversation we're going to be having because we have someone I've known for a number of years, and I think is doing something truly amazing that not everyone is doing. We have Derrick Gakuu, who's the founder of Siscom. He'll speak more about that. But the reason I'm excited about this conversation, even before we introduce the previous episode, is because we are having a conversation about something we don't usually speak about. We are having a conversation about infrastructure in AI. And there's no one better that I know, at least in the continent, who can speak about this topic than Derrick, and you'll hear why that's the case. So in our episode number 8, we had Dr. Siscom Gitau, who's the founder and CEO of Kala, which is a data and AI digital transformation company in Africa. And we had a super exciting conversation. We spoke a lot about AI and language, right? And we spoke about this idea that, if we're not able to localize AI by having AI in local languages, just what proportion of the population in the continent will miss out. And we also spoke about this idea that when you look at the big AI models, they've not been created, at least they've not been localized for us in the continent. And so we have to do a bit of work as people in the continent, the talent in the continent, the investors in the continent, in terms of creating infrastructure, creating talent that's able to take these models or create our own models that can be used in the continent. Talk about healthcare, talk about education. There's so many use cases. Talk about government services. There's so many use cases that we can take AI as it is and be able to apply. So she could challenge everybody that we should not be scared of AI. And she used this terminology that AI is this big bully that thinks that it knows everything, and you have to challenge AI back. And she said, even if you've not started using AI, it's not too late. You can still join the bandwagon, and you will be able to make something out of it. And I think the last thing that I want to mention about that conversation with Shiko is when you asked about what she would do with unlimited AI resources, and she said she should create an AI model for Africa. I thought it was a really good conversation. Please, if you want to listen to that, listen to our YouTube, go to our Spotify. You can reach with that conversation, or at least, go to our Substack where we put notes on all the different guests that we host. So, to Mr. Derrick Gakuu. So I've known Derrick for a number of years. But the first time I met with Derrick, he was looking for funding as an entrepreneur. He's still looking for funding. So I'm sure that's going to come up. I've not been able to solve his funding need yet. But hopefully this helps him to move closer to that funding conversation. But just a quick introduction about him. He's a founder of Siscom, which is a Nairobi-based digital infrastructure company, which is building homegrown cloud, compute, and AI infrastructure for Africa. His infrastructure is locally hosted, and it's in line with data sovereignty laws. So Siscom is preparing to launch a locally owned GPU cluster for AI training and research, and has pioneered a crowd-invested model that lets ordinary Kenyans co-own cloud. I saw a YouTube about you, Derrick, the other day on YouTube, which I think has gotten quite a number of likes, and people have quite a number of views also. Just talking about this idea about owning infrastructure and how attractive that is. And his whole thesis is that Africa cannot keep renting its digital backbone from AWS, Microsoft, and the rest. It has to build and own the rails itself. So, Derrick, I know that I've done a fair introduction of you, whether you want to add something to that introduction.
Absolutely. I think, thank you very much for having me on the podcast. I think it's a very good platform to share these type of stories because, that's, we are sitting at the intersection of a new, they call it a new industrial revolution, and a lot is going to happen. The good thing is that with AI, everyone seems to be at the same starting, right? So the winners and losers, obviously, they have themselves to blame 10, 20, 50 years down the line. So my name is Derrick Gakuu, like you said. I founded Siscom just to focus on one thing, and that is how do we actually get digital infrastructure funded. So the majority of the people, when we hear the cloud to an ordinary person, the cloud is up there, right? However, cloud is a bunch of high performance servers. In this case, Air Cloud is a bunch of high performance servers, clustered with GPUs, which are specialized chips that actually process multiple computational requests, perfect for AI, sitting inside a data center, running 99.99% of the time.
Derrick, stop. Now I'm going to make you speak in English.
Okay.
understands the language you're speaking. And I don't know that everybody that listens to our podcast understands the language you're speaking. Derek, before we sort of like jump into that, I wanted to just mention one thing in terms of why, I thought this was just a natural conversation from Shiko's conversation, right? Shiko spoke a lot about sovereignty. I think Steve Tavia spoke about sovereignty, and you're hitting right at that element of sovereignty for a country, for, I don't know, for a company, when they start owning their infrastructure and so forth. But just coming back now to what you're trying to explain here. So maybe just in English. So when people say about cloud, they imagine that the data is somewhere in a cloud somewhere. When we hear that the data is being hosted in the US, some people do not really understand what that means. If we, for instance, you walked into one of the I don't know, data centers that you probably own, or you're putting part of the infrastructure in, how does that look like? Where, I mean, I don't know if you can tell us where it's located. Is it a room? I don't know. Is it I don't know, a room that is size of a stadium? Is it a small room? Just try and walk us through. We start with the basics, then we can move on from there.
All right. So using Jensen Huang, who is the CEO of NVIDIA, I'll try to explain what digital infrastructure is and what it means to everyday people whenever they interact with their data in different forms. So you have at the bottom layer the foundation, which is power. So every time you hear about data centers, the conversational power always comes up, and that's why a lot of data centers will quote their IT load in terms of the power they consume, right? So power is very essential because these high performance machines running 24/7, 99.9% of the time consume a lot of power. So that's the first infrastructure that is key for data centers. Then the second infrastructure is actually the data centers themselves. So think of data centers as warehouses that house high performance servers, sitting inside them, and they also create, what we call interconnectedness, right? So the servers themselves host the data or store the data, but for that data to get to your phone, there has to be an ISP, who is an internet service provider, a carrier who actually transmits it to you. So in your house, if you're using fiber, then let's say if Safaricom is your fiber provider, then that becomes a carrier, the person who actually sends your request to the server in the data center and fulfills the request back to you, which is upload, download, right? And then if you're using, let's say, your mobile phone, then that's going to be tower technology, which is just a cellular type of connectivity. So that forms the foundation of any digital infrastructure conversation. Power, the data warehouses, the data center warehouses themselves, the servers that run in those data centers, and then the ISPs that carry that data between you, the user, and the server. All right. So think of it this way.
Just for context, Derek, as we continue, right?
Yes.
There's of course a hard drive where we store sort of like the data. Then the server that processes the data. You're using that terminology interchangeably, right?
Exactly. So a server is, think of a server as just a specialized high performance version of your computer, right? A server is just a computer. It's a specialized high performance computer that has compute, which is the processing power, which is what you're saying, which is what processes the requests. It has the RAM, which is the memory, right? And then it has hard disks, which actually store the servers. But now this type of machines are enterprise and specialized, so they're also very high value, and of course, that's why they call high performance compute, right? So now, even with that sort of thinking, air infrastructure, while traditional servers run on CPUs, which is central processing units, the difference between that and GPUs is just GPUs are just a more robust version of the CPUs. So while CPUs process only one request at a time, GPUs are able to process multiple requests at a time. So they have more compute power, they have more RAM, and so forth and so forth, right? But now, back to your question. So what is the mental model of a data center? Data center tiered differently. So as an example, you walk into enterprise offices, and you'll find they have a server room. So that server room is what is called a tier 1 data center, right? It's just a small cluster of servers. Why they are tiered is because of the redundancies that they have, right? So now your office server room will probably not have a redundant power. So if the Kenya power goes off, they probably have just a basic battery that can provide redundancy to just keep the workloads running. But then if that goes out, then it means there's going to be downtime, which is also what we have in terms of tier 2. Tier 2 is what you'll find mostly in banks. So they have some form of advanced redundancies, but not entirely there. Now, the tier 3 data centers are what have formed the big conversations in Kenya. So if you hear IX Africa, where we co-locate ourselves. We don't own data centers, but we work with data center partners like IX Africa, Pan-African Internet Exchange. You have iColo, you have Konza Data Center, and then you have the more traditional or more edge Africa data centers. So these are tier 3 data centers. Why are they called tier 3 data centers? Because they have what is called N+1. N+1 is redundancies for power, cooling, and so forth and so forth. So what they guarantee their customers, who are cloud operators, ISPs, enterprises, is 99.99% uptime. So the workloads never go offline because they have, as an example, you'll find that they have 2 substations on premise. So let's say if one substation of Kenya Power goes off, they already have a redundant one. Even more than that, they have gensets on sites that equal a certain percentage of the power they have. So as an example, I'll use a good example of IX Africa, which is one of the only AI-ready hyperscale data centers in this region. They are a 14 megawatt IT load data center. So it means even the redundancy they have in place, generators, they have the battery backups, they have the UPS, must equal the amount of power under production. So this is just for the benefit of the people that actually put their servers or the equipment inside that data center, because now they will never go offline for whatever reason. There's always backup for everything. So that is tier 3 data centers. Tier 4 have now an advanced version of that, right? Now, tier 4s are mostly not in this region because we don't need them, because they're very expensive. They are big investments, and mostly they're found in the US. So for tier 4, it's now you have a data center on one side, data hall on one side. You have to have an equivalent of that data hall on the other side. So to always provide that 100% guaranteed uptime. One of the things about data centers is actually the cost of building and setting this up. So as an example, again, I will use IX Africa because that information is publicly available. There are $50 million, investment in terms of infrastructure for their first campus, right? And they also recently raised $200 million to build the next campus, which would be around 22 megawatts. So that's just the mental model of a data center. It's a warehouse where people like us with high performance compute can rent space, put our servers, and run them, paying for electricity, cooling, and that leasing of space.
Thanks for painting that picture, and just also getting the tiers now, tier 1, 2, 3, 4 in this case. So let me ask a basic question.
Yes.
Of course, a number of us use AI, right? I use AI, we use Claude, ChatGPT, and so forth. So at the moment, just for someone who doesn't know, where is my data at any one point, and why can't my data be stored here in Nairobi, for argument's sake? Let me start with that basic question.
All right. So now we'll go back to the conversation of CPUs and GPUs. So while a lot of advancements have done in cloud, traditional cloud, there's very less that has been done in the area of artificial intelligence infrastructure. So like I said, AI needs certain specialized chips. And that's why you hear a lot about GPU, graphical processing unit chips. Of course, these are mostly manufactured by the most valuable company in the world, which is NVIDIA. So you'll hear NVIDIA GPUs, and then also AMD, which is a chip manufacturer, has also come into the market. They also have a lot happening in China with their own AI infrastructure investment. So these chips are what processes your AI requests. So think of an AI like your brain, right? While a CPU can only process one request at a time, a GPU can process multiple. It's the same way I am speaking to you right now, but I'm thinking at the same time, and I can look around at the same time. That is the power of artificial intelligence. And for that to happen, it needs now these chips that are able to do this type of workloads simultaneously. So currently, there's been a lot of advancements in personal AI, which is just the chatbot. Chatbots to interact with OpenAI, Claude, Gemini, all this. So as an example, if you are using OpenAI as a chatbot, your data is being, and requests are being processed on GPU chips that are hosted by OpenAI data center partner. And in this case, I'll use an example of CoreWeave. So CoreWeave is one of the biggest AI infrastructure data center companies in the US. So that means every request you're making on OpenAI is actually being processed in the US, not on the Kenyan soil. Okay.
Wow. Okay. That's good to know. Hang on. Sorry. You only finished your thought. I was just going to ask you, why can't it be hosted here? But I guess you'll go to, do we have the GPUs here in the first place? Does Siscom have the GPUs?
Exactly. So the truth of the matter is, again, these AI companies have been here for quite some time. From 2015, you can see the massive investments that sits behind them. because the truth is infrastructure is not cheap, right? So as an example, let me use, now that you're talking about large language models. Large language models are the engines behind AI, right? So you train a large language model, then it fulfills requests every time. So in this case, for as an example, they have the Fabo 5, Sonnet. Those are the large language models that actually process the requests. So currently, I'm not aware of any large language model coming from Kenya or coming from Africa. I've not seen one. I'm not aware of one, right? So most of these large language models are mostly private. So if you look at OpenAI, they have private large language models, Claude private large language models. But there has been, which is a good, which is something interesting that is happening in the space. There's been a push for open source large language models. So source language models are like open source software, where you don't need to build it, but you can use it to train your own agents. You can use it to train your own chatbots. And of course, everything that is open and free, it means you are the person that is providing the data to train it. You're the customer, right? So there has been companies like now Google. So Google has an open source large language model called Gemma. Gemma, I think Gemma 4B. You have the most popular one, that's the ones that are, for example, ourselves at Siscom are experimenting with from Meta. So you have Olama, and so Olama, and every large language model will have a number after them, like 70B, 4B. So if you see 70B or 4B, so 70B is it means this model was trained on 70 billion parameters of data. That is massive. So I'll put context into this. So Olama, I think it's the latest model by Meta, which is a company behind Facebook. Was trained on 180,000 hours. Okay, which GPU specifically they used to train this model? They used a cluster of 24,000 A100s to train this model. Now, in the global markets, an A100 is $50,000. So you can do the maths. Even if you have 1,000, you have 10 of these, because 10 can form a half rack of a cluster in Kenya. That means you're already looking at $500,000 worth of investment. 100 is $5 million worth of investment. 1,000 is almost $500 million. That's capital that is not available currently, right? So that is why we don't have much GPU footprint in Africa, right? So let me just put perspective into that. So currently, America, as a market leader, has 2.5 million GPU chips currently under production. In fact, they're one of the most popular leased data centers with leased GPUs is XAI, which is used to train Grok models. Grok large language models, just Elon Musk company. They have 550,000 currently in production training their models. OpenAI, of course, is a market leader in terms of GPUs currently under production. While Africa, as a whole continent, we have plans to actually deploy 12,000 plans, not active in production. We only have plans to deploy 12,000, and I think less than 5,000 are currently in production, with 3,000 of these actually being owned by Cassava AI, which is again public news. They partnered with NVIDIA to get some 10,000 GPUs, specifically H200s, and the 3,000 that are currently in production are in South Africa, in Cape Town, in Cassava data centers there. So that brings the current, maybe active GPUs in Kenya, maybe less than 100. All right. So for us, we have very few. I think we've just recently done the V100, Tesla V100s, because we're experimenting. Tesla V100 is a chip technology by NVIDIA, but it's more of from 2021, 2020. So it's like buying a version of a car from 2015. It's cheaper, that's the thing, but not at the level.
Not at
because these are the most
affordable ones. Yeah.
Yes, these are the most affordable ones, because they're like what? They're like $5,000 each, $5,000 each, and you still have to ship them from Dubai, because then they have become available in the aftermarket. So that's just the scope of the gap in terms of GPU footprint in the continent, and that is why we don't even have a large language model, because where is the infrastructure to train it?
Interesting. And so just for context, I have this statistic that I don't know, the numbers are something like China has maybe like 10% or something. Then the US has like 90%. And then Europe has a rounding number, so to say. Is that the case?
Yes. So digital infrastructure and before GPUs, it's still, a numbers game. So as an example, America has 5,000 data centers, 3,300 of these are in what they call it the data center hotbed in Virginia, the state of Virginia. They have 3,300 there. Now they're doing massive build outs, especially just preparing for AI. Kenya, we have less than 10. So you can already see the maths now, because now for AI it needs a different type of data centers because of the amount of power a GPU chip pulls. So while a traditional high performance CPU server will do, let's say, 5 to 10 kilowatts per month of power, if it's running at capacity, a GPU is going to do, cluster will do almost 200 kilowatts of power. So data centers here price, their business model is actually, like I say, it is of power and the renting space. This is just real estate. So we call it digital real estate. So they charge, for example, they charge averagely 250, 350 kilowatts. So you see, they charge you for how much kilowatts you consume in their data center. That's a business model. So now with AI, it's crazy. So you can just do basic maths. If you have a cluster that pulls 100 kilowatts per month times 250, you can see the amount of investment that is actually needed.
That's required.
Since that capital is not there, that already can paint a picture of where we are as a country, as a continent.
And Derrick, so then just jumping onto this question, right? I know it's an obvious one from the numbers you've given us. I'm going to still ask it, right? Why did you found Siscom? Is this what you're looking at? I mean, it's an obvious question based on the kind of numbers you're giving us. But I'm curious in terms of also, is there a return from all these? And I know we're not talking about AI yet, where we want to go, but I'm just curious just to hear about Siscom and what's the thesis behind that.
Yes. So my first, during that, I worked a lot in payments, and payments was one of the industries that, payments, banking, financial services is one of the industries that really have massive demand for capital, right? Massive demand for compute, because, you have to maintain transactions per second, all that. So my experience in payments showed me how much companies in that space actually spend, in terms of, cloud spend. Now, one of the challenges, because it's also a heavily regulated industry where the expectation is that you have to, data sovereignty, data localization, where personal data, transactional data has to sit on the soil. I figured that there was a problem with the policy or the law versus what's the actual picture on the ground in terms of supply and demand. So you find less supply, and this is basic economics. When the demand is up and supply is low, prices are crazy. Right. So we found that now a lot of companies have to work a lot with the global cloud providers like AWS, which one doesn't have a data center or a cluster in Kenya, which means already you're not complying. Secondly, you're paying in dollars. So it means if anything happens to the currency, your bill goes up without you necessarily having to transfer that cost to the customer. So I figured this is a problem that needs to be solved. So we did a lot of work last year, working, moving around data centers, working with cloud companies, trying to understand where is the problem. Why don't we have an AWS version in this market? And the problem was crystal clear. It is the capital base these companies sit on. So while AWS is, while AWS CoreWeave are majorly funded by, digital infrastructure financiers like Digital Breach that have massive institutional capital sitting behind them, we don't have those capital markets in this side. So for us, and our vision was very simple. Let us solve for the problem of finance, right? So now it's a bridge. When you look at the demand side, which is the infrastructure operator side, versus the supply side, there's a mismatch, right? A typical institutional investor in Kenya does not have a mental model of how digital infrastructure looks like, the assets in that market, how to commercialize them, what's the return on investment, how to collateralize them, right? So it's been quite a journey. Interesting. We did some private placements. We did some clusters at IXF just to look at the experimentation part of it. And then we realized now what we need to really build are technologies and systems that can collateralize digital infrastructure, right? So currently we have two systems that we are maturing. The first system is called WASP. WASP is a rack monitoring system. So what it does is just it monitors the rack, in terms of sharing rack space and collocation. Then we're also building Weave. Weave is supposed to monitor utilization, tokenize and allocate, in terms of compute, now the GPUs and the high performance servers. So the idea of these technologies is to bring visibility so that if we walk to a bank or we walk into a financier, we can tell them, okay, this is how GPU per hour works. This is how compute per hour works. This is how power works in data centers. Now, when they have that data, then they can start to create the mental model and understanding of how capital can flow. So our vision has always been getting digital infrastructure and air infrastructure funded in these markets by looking for alternative sources of capital, right? Yes, while the West is private equity, hedge funds, and those big capital markets, for us, we're then asking ourselves, how do we get small institutions like a Chama, a pension fund, like a bank, actually understanding how to finance this, because they model at the same. They work like real estate or warehousing, right? People lease space, they pay. There's a clear path to revenue. Now, if you look at your ideal cloud provider, right, in Kenya, these are companies that provide cloud resources to businesses that need ERP hosting or running financial services. They have a return on investment of 20% year on year, 20 to 21%.
Is that dollars or KES?
20%, the capex is in dollars because this is infrastructure that is shipped from abroad. So they have 20%. But this is when they'll have to take at least 3-4 years to recover their capex. Why? Because the cloud company is trying to finance capex from their own balance sheet, right? Which is extremely painful to scale, right? And then it means now 3-4 years they're funding their capex instead of investing in innovation, investing in growth, investing in marketing. Now, one of the cloud providers actually went to a local bank and said, why can't you collateralize servers? That mental model was not there. So this is the problem we're solving. We are bringing these computes on-chain, right? And then now if they go to a financier, they can tell them, okay, now see, this thing works just like traditional real estate, works like any other asset. If you finance the capex, which is the GPUs, the high performance servers, now you see what the business is actually doing is either doing operating leases or they are leasing to own, which now means they don't have to finance this off their balance sheet. This is what our
So basically, the key question you're asking yourself, Derrick, is how do we turn digital digital infrastructure to just basically real estate? We think about it as real estate the same way people over the weekend, they spend their time going to check whether their plot, at what level it's built, what's the occupancy, etc. That then people are able to appreciate that you can also generate just as good a return by making investments in digital infrastructure in this case. And I believe based on where the world is going, based on the kind of conversations you're having about AI. So you mentioned something that I thought was interesting. Yeah, you spoke about this idea about laws in terms of fintechs and so forth, that the data has to be processed locally, right? Which then means, if you're a startup, if you're a bank, etc., the servers cannot be on AWS. They need to be owned locally. So let me ask you a question. Do you see the government passes a regulation and says, you know what, for your AI use, the the data has to be stored locally? Do you see that happening? Are we very far from that, just based on the statistics you shared earlier about just how expensive it is, first of all, to have the infrastructure you need for it, and just how long it takes to be able to put this. I mean, I've had conversations where people say that right now, if you wanted to get GPUs for NVIDIA, you just don't order tomorrow, right? You order and they tell you there's a wait list. So we're going to get your stuff maybe 6 months from today, 1 year from today. Do you see a world like that where we are forced by data laws, data privacy laws to have the data locally?
Yes. So already, first of all, the laws exist. So Kenya already has, the data protection, data sovereignty laws. Just that compliance hasn't been at that level, and because of these usual challenges. But not even regulation, the market itself will push and create that ecosystem. So right now, there is a lot of personal AI. You and me, I can download my data and put it on cloud. I can download my data and put it on OpenAI. A lot of banks have actually blocked those chatbots from being used by their own staff. You can imagine a customer in a large bank downloading data and uploading on Claude, maybe to generate a reconciliation. They are not allowing that. That only means one thing. That only means one thing, that the demand for private AI. So private AI is going to be a demand by enterprises. They're going to say, we need our data to sit locally. So we need the AI application to also sit locally. And we have done this through something called AI Lab, where we've been speaking to, especially microfinance, banks, aviation, And the question has been, okay, where is the data being processed? One. Two, if now my data is being used to improve this model, whose IP is it, right? So this is why maybe even in your, even the previous session, the guest said we have to build local LLMs. Now, building local LLMs is a bloodline, right? So what's going to happen is that because of that demand for private AI that sits inside the country or sits inside a high performance server, inside their cluster, it means what is going to happen is inference. And inference is a big deal. So inference is where you take a large language open source model, all right, you deploy it in your own GPU sitting inside the country, and then you build the agents on top. So agents can be a reconciliation agent, customer onboarding agent, customer care agent, let's say customer service or customer retention agent. So all the things you interact with on chatbot, those are just agents. They're called agents because they mimic what human beings will have been doing. So let's say if a bank has, let's say 100 employees, a team of 100 employees, maybe at peak, you'll only have 20 people interact with it with their own chatbot. So think of an OpenAI, a version of OpenAI sitting inside your desktop locally, controlled by as a local environment within your firm. So now the advantage of running inference is that unlike large language models, they don't need too much compute power to process them, right? So while you need GPUs to train, let's say, a large language model like Llama, you just need, let's say, need a cluster of 10 A100s. That's the reality. Inference is going to be our silver bullet as a country and as a continent, because just training a whole large language model is intensive. Using think of inference as using an already trained large language model. Companies are now doing open source. We've seen the big news by Jensen this week saying open source is going to be the way. So you take whatever model, you put it in your own server, then you run your agents on top of that model. So now it protects the data conversation because the model interacts with your data, whatever it is. It can be in your tier 1 data center, tier 2 data center, which runs on traditional compute. The application itself is often to run on a GPU.
Okay, so let me slow you down and just make sure that you understand this concept of inference. So I think it's an important one because I know there's probably a CEO somewhere who's listening to this conversation and probably needs a part of it. Just like I like what you're speaking about because number one, the cost of licenses for Claude, Copilot, ChatGPT, they're just crazy at the end of the day for a company. And then there's this question people are asking, even if I want to deploy, I can't give it to everybody in the organization. But I would imagine if I have a local model, then I can give it to pretty much everybody because my cost is not as incremental in this case. Right now, it's per license, which means that I'm paying ridiculous fees. So then it's a very important conversation for someone to understand. So let me get this straight, yeah. So you take a model. Let's use Claude because people are using quite a bit of Claude at the moment. Number one, do you have to pay Claude to sort of run the inference, if you want to call it that, in this case? Because what you're saying is that you're using their model and then you're building on top of their model in a way that it's not, you don't have to keep routing your data all the way back. So number one, do you have to pay a Claude, in this case, quote unquote? And then secondly, just to make sure that we learn the concept, because and these are most asking for myself, right? There's this bit around the model is still there. They're the ones who are still improving the model every single day. How do I ensure that my data then is not the data that I'm running on the model is not going back to their side, especially when I need my model to keep being improved, the cloud version that I'm using to keep being improved? Just explain that.
Yeah, so it's an architecture setup that is very complex. However, I'll try to
in English. Please explain in English.
It make sense to a decision maker. So you'll definitely not use Claude because Claude is private. So their models are private, right? And they charge for them. They charge the token. In fact, like you so rightly said, the tokenization pricing model is never going to be sustainable for enterprises, right? Where people have to buy enterprises because enterprises work on very predictable fixed type of costs. So you don't want a situation where now your IT team is doing $100 every month in terms of just buying extra tokens to do what they're doing, because the tokens is just infrastructure. They're just selling infrastructure in the cloud. So all the private models are out of the equation. So private models are OpenAI, Gemini, Claude are out of the picture. But these companies that are doing open source models, so you don't pay, all right? But they're doing open source because they also want to improve the LLM itself, not really the application layer. right? So as it is today, you don't pay for the open source model, right? What you do is that you orchestrate your application, because you're only building agents. What the business wants is an agent that can, let's say, verify a customer, an agent that can look into data and see which customers are more likely to churn, an agent that can respond to customer queries via a chatbot. So that's the application layer, right? That's what mostly the business will be building. But that application layer needs to sit on an LLM. So what it does now, it communicates to the LLM, the open source LLM, via API, right? Now fulfilling that request is what is computational. That's what is deployed on your own cluster running inside the country in terms of GPU infrastructure, right? So only if the LLM, the open source LLM that you've deployed locally, does not have understanding of the question, the query or the prompt is being given, you can also architecture it in such a way, which is what is being referred to as RAG, in such a way that it communicates to let's say, the available online or cloud-based models. But because this is really localized within an organization, just having the agent sitting on the LLM, because LLM is the engine, it's the brain, it's what understands the request, completes it, returns it, now communicating between the agent, the LLM, and your data. Because remember, AI is all about data, right? So data sits where it sits. So let's say today, bank databases sit on their own cloud, locally on their own premise, or they sit on their own cloud somewhere in a local data center. So all this is API conversation where these applications just speak to each other without necessarily having to transfer the actual data, let's say the actual databases, to the cloud. They still run in a privately controlled environment. Since it's still a new area, now the question of we're improving this model, who benefits is still not figured out yet. But it's a bridge that mostly IT managers will cross in once they get there. Once at least they have their people using AI, right? Because their teams are requesting, they're saying we need to use chatbots. They're requesting, they want to use chatbots, but they're saying we can't use because it's not private.
Okay, I'm going to ask two questions. I wish we had a whole day for this conversation. We do need to start thinking about how we, wrap up and we get to ask you some of our signature questions. In essence, what you're saying is that, for the people who maybe have not, understood it completely yet, it's almost like, Linux versus Windows, right? Linux was open source. You could do whatever you needed to do. Then Windows, you have to pay for. And so there's some companies that just said to go the Linux way because it couldn't stomach having to pay that bill on a consistent basis. Now, one question that comes up, and I've had this question being asked by people who went the Linux route, right? There was just this view that for you to be on Linux, you need to be just very technically competent. You had a really good IT team that's able to, do all the apps you need now on top of that, right? Your Excel, your Windows, your Excel, your Word, your PPTs, and so forth.
Yes.
And then there's also the question of, security, right? With these open source models that out there right now, I think I've read Kimi. I think just released their open source model, the Chinese model in this case. And there's a question of what's happening in the background in this case. Maybe just speak about those two elements of the requirement for you to have the tech requirement that you need in terms of the human resource, and secondly the security aspect, which I think is a key concern for most people.
Yes. Yeah. So that's why I think AI engineering is going to become a very key area for guys out there who are AI engineers who are training themselves, because that skill is going to be very much in high demand. Because AI engineers are the ones that are going to be the agents, are going to figure out how the agents communicate to the large language models, where they are deployed, and how that infrastructure architecture, protects costs at the same time tries to answer the question of security, because you can't have it all, right? The guy who is on Microsoft, but there's the guy who is on Linux there. These things are seeding. You always have to give something. Yeah. So if you want open source, there's a price to it. They say online, something that is free, you are the customer, right? So that's always going to be a question.
Give me so much comfort when you say that if it's free, I'm the customer. So I'm just curious. I'm just wondering.
Yeah.
How am I the customer? But anyway, as you say, then you have to invest in some really good tech talent.
So that's how it is. It's on privacy. At least if the model is communicating to your data, sitting wherever it is, at least then you have some sense of data security. But like I said, it's still a very much gray area. But you see, before all that happens, you still have to answer the question of infrastructure. If you can run your own cluster as a bank at IX worth $1.4 million, then you see well and good. So it means you you will. But if you can't afford that, there's ground you have to see at this stage, because none of these things are local, which is why it's very important to make them local and invest in them and all that.
Yeah, and that's part of the reason why, I think this is such an awesome conversation, because you're trying to then give a solution, at least an alternative, because at the moment it's like we just have to give it to the hegemony of the big AI companies.
Yes.
And we can't do anything about it to a certain extent. But this is a good option where you can have your own local, local infrastructure, run your own local models, which might be costly, I guess, in terms of setup. But over a period of time, the sense I get is going to be much cheaper for you because it's not per license anymore. So let me ask one other question on the macro, then let's move to the specific a bit, or rather to the micro a bit. So this question of sovereignty, people are obsessing a lot over that, right? There's this question: do we need to own everything in the value chain, right? Can we just be okay with Claude, ChatGPT owning our data and just say, what, they're companies, they're regulated, we can sue them if things go bad? Do we need to own everything? I mean, what's the fear there? Just fear from you.
Yeah, so you don't need to, and globalization doesn't work like that. You just need to own what is essential. But as we push for, because AI infrastructure, digital infrastructure is becoming a national conversation the same way you look at power, right? You can say, do we need to have our own power infrastructure until your neighbor, you're in conflict and they switch you off? So this is the same thing. 2 months ago, the US had actually prohibited NVIDIA from selling H200s outside the US. So these are the sort of things you can, the American political environment can change, and they say, we have an issue with this country or Kenya, and none of our companies can do business there. Now, all the things that you are depending on that are American or something like that, now you don't have access to them. And, that's just the first part of it. But even recently, you can look at the conflict in the Middle East. Okay. The conflict in the Middle East exposed some gaps in the importance of sovereignty. So there was a conflict, and I think Iran allegedly hit some data centers in the UAE. So there was AWS East One, and then there's Microsoft data centers, and there were customers in Kenya that were actually affected. So they had their whole, I think it was ERP offline for like 2 weeks, and they couldn't process a customer request because that ERP is hosted at that particular data center. So you as a Kenya customer have nothing to do with the conflict, because your data is processed in a data center in that country. Now you are collateral damage. You see, now if they were running
because I was paying attention, I thought these guys would be on tier 4, not on tier 3, because I thought tier 4, you sort of like you're running in parallel the same data center, so to say.
Yeah, but you see, it's still within the same campus, just, double. So if the campus is hit, it's hit. Right. So that I think that conflict really painted the reason why some things should be inside your country, and especially if the application doesn't need to communicate with applications outside your region, they should just sit in a data center inside your country. We don't see the problem with that, because then that also brings up another conversation of latency. Latency means the further away the node or the server is from your user, the more it takes to complete a request. It's like, if you have a server running in the next room, your user has an experience of super fast data exchange, right? So latency, and then data is a very valuable resource. Honestly, if all factors are notwithstanding, you can imagine the sheer amount of value intelligence from data creates. So if it's being processed by a foreign cloud company, they're the ones that are benefiting from the benefits of that intelligence that sits inside your data. If it's sitting inside your country, your cloud companies and your data analytics companies, they're the ones that are pulling value from this. And pulling value can be new innovation, new products, AI applications like this, because even currently, large language models, like I said, most of them have been trained on at least 4 billion parameters of data. This data needs to have been clustered, cleaned up, so that it actually even makes sense to the agent. So even that is a challenge currently. If someone says they're building an LLM, where is the data? Yeah. Is the data siloed? Do you have big data parameters that someone can actually train a model? We don't. So this is the benefits of making some of these things sovereign, because then there can be laws that can harmonize, let's say, data in the financial services industry, and make it available to people who want to build AI agents, like credit scoring, customized investment solutions. When that is not figured out, then you can see the price that you have to pay.
No, I can see it clearly. You much when discuss just simple things like government services.
Yes.
GOK for e-citizen, they're using a model like you're saying now in this case, whatever the servers are not here, and then it's hit.
Yeah.
Do we say that then we
Yeah.
cannot run on
Yeah.
government services? In this case, if Safaricom was using
Yeah.
or M-Pesa, I don't know if our servers were
Yeah.
out. And, it's very, you can start now seeing sort of like how critical that is. But let me ask the next level of the question, right? One of the other layers that people have been talking about is, I also have my own personal data, which at times I'm not comfortable sharing, right? I think I've read somewhere where they were saying that one of the key use cases for AI has been therapy, right? Where people just go
Mm-hmm.
in, they download their problems. Oh, I'm having a problem with, I don't know, with my partner in life. I'm having a problem with what. And at times you want to sort of like have that conversation in a private kind of environment. So when are we getting this on my machine? Because that's the next level. Or at least in my house, I have my own Karak somewhere there. Is that coming anytime?
No. So again, remember the 5-layered cake. If you find time, just search the 5-layered cake of AI value chain by Jensen Wang. He spoke clearly about these things, right? So power, chips, power is the first layer, chips are the second layer, which is what NVIDIA play. Infrastructure, data centers, connectivity, networking, that's the third layer. Large language models are the fourth layer. Then applications is the fifth layer. Okay. So what you're referring to is applications. An AI application that it's a mental health AI, right? It's the application layer. It cannot exist without the rest of the layers. So for you to do that,
But
it means
exactly, that's my question. Like, can I have the rest of the layers in my space in this case? Like,
there has to
I know
be
it's a crude example. It's a crude
there
example.
has to be there has to be the ecosystem. There has to be. That's why for us we say we want to play in the ecosystem as people that can enable finance to flow, so that other people can do the rest of the things. There are people that can do power, Kengen, Thermo, data set, chips. Chips we don't see as manufacturing chips, but it's fine. We can import them. Large language models, data centers are there. Large language models can be built if the first two layers have been figured out. Then now we can have, which is where we see a lot of innovation in the Kenyan ecosystem. People who do the agents, agentic AI, chatbots. That's where you're going to have a lot of applications. So the more we drive capital for the industry, the more we can enable innovators and AI scientists who want to build the AI agents like you're speaking about, and then they can be Kenyan. So then you are sure at least the Kenyan company, they have conformed to the laws, let's say, of the Ministry of Health in terms of how they can bring such a health AI application into the market, as opposed to using an American Chinese one that you don't know which laws they have subscribed to and you don't have control over. So it takes the ecosystem to just do exactly what you said. And there's going to be use cases in agriculture, which is in maybe precision agriculture. There's going to be financial services, reconciliation agents, personal financial assistance. There are going to be use cases in healthcare, which is genomics and all that. There's going to be use cases in personal AI, just scheduling your day, planning your trips. Aviation is going to experience a lot of disruption with AI agents that can book a trip for you, get your flight, plan your hotels, and just give you one API point where you make the payment. So all these applications are going to come there, but they can only be localized if we have the rest of the ecosystem, power, chips, data centers, models figured out. Otherwise, they'll be building on foreign or LLMs.
Okay, wow. I really wish we had more time because I feel like just peeling the onion, all the different layers. I think we'll probably invite you back just to keep peeling this onion layer. But we want to get a bit personal just to understand you a bit more and how you use AI before we can sort of like wrap up the episode. So let's move to, let's move to your company, now. And let's just say if I walk in, to Cisco, right? Are you using AI? How are you guys using AI practically in this case? What kind of impact is it having? Maybe just showcase one use case for you guys that has really helped the organization to move forward. I'm just curious, I can hear more about that.
Yes. So, personally, I've used AI in so many ways, especially in terms of UI UX. So UI UX was is a whole skill. That's why in product development you always have a product designer, and most of these are not cheap. So a good UI UX person in Kenya will cost maybe $1,500 to $2,500 per month. right? And it means if you really want to build great UIs, websites, you have to be able to afford that. But now with AI, especially Figma, there's Figma AI, and there's a lot of AI applications that actually do very good job, in doing that. So we've been using AI for just UI UX in terms of our on product designs, system and application design. Of course, we use UI, AI to support our financial model because, like I said, even what we're trying to do is not new, something that has been done in the US. So if you look at companies like Digital Bridge, they primarily mobilize capital and invest in digital infrastructure. They do data centers, AI data centers, they do tower, they do microcells, they do fiber technology. The other, just in 2023, the company I spoke about, CoreWeave. CoreWeave was able to collateralize their GPUs and raise $2.3 billion from the likes of Blackstone and all that. So think of it this way, Blackstone and Magneta Capital raised $2.3 billion for CoreWeave against the existing GPU infrastructure. So that is collateralization, the same way you collateralize a mortgage or collateralize a vehicle. So we use AI again to support in that. But because we are trying to also look at asset classes in AI space, we have currently, like I said, we have some chips. What we want to do in the next quarter is to actually run real applications on these chips so that we're able to simulate utilization. So we actually working on our own reconciliation agent, AI, and building that on top of open source large language model, in this case, Gamma 4, because we want to see in real, practically, how would a Kenyan AI company deploy an agent on a chip? What is the utilization like? What is the power? What are the moving parts around it, even before you say this is an asset, right? So we do practically on the building side, but in our own operations, we use AI for product design, even sometimes product development, and then financial model.
Okay, wow, good to hear. And please will keep us updated in terms of you're running your own AI model using Gamma 4 in this case. I think we'd love to hear how that experience went, so that then as other organizations start thinking about the same thing, we can tell them, these are good use cases, and so maybe they can follow in the same footsteps. So as we do in China AI, we have some signature questions. And I'd like to run those by you to see what your responses are going to be. So the first signature question is, what is one AI habit you have developed that saves you a lot of time on a daily basis, on a weekly basis?
Planning my week, planning my month.
Okay. How does that look like? Just to get a sense, when you say planning your week, planning your morning, how does that look like?
Yeah, so I'll mostly made it look like a personal AI. I'll tell it, okay, this is the things I think are important for me this week. Can you figure out what is noise and what I should double down on? Then we discuss with it. Then it tells me, do you think this is good use of effort? Then we come down to the 3 main things per day that are going to define my week. Then I tell it now, can you link this to my Google Calendar? So that these are the 3 meetings I think are important. These are the 3 things I need to chase. These are the 3 things I need to close by end of week. So it has really helped to not try to be everywhere.
Wow. And I'm glad that it's recommended you come to China AI.
Yes. It reminded me.
It's recommended on top of that. But let me ask, so what does it take in terms of someone training that? Because there are times we speak about these things, just like, wow, that sounds fascinating. I wish I could do that. What does it take? Do you need to be, do we need to be you? Because, you understand this stuff, like it's just pouring out of you. You're just like GPUs, Like, can I create something similar?
Yeah. So, yeah, like, AI improves, with more data and you feed it, right? So you just need, first of all, to be consistent. If you choose Claude, you stick to Claude. Then you have to keep if you are using a certain model, you keep that model, because every day you interact with it, it gets to know much more about your personal or professional stuff. So it has that thought process. It has that memory that, oh, this is connected to this. Was this linked to what we were discussing last week? And I think personal AI is going to be the biggest industry in the whole AI thing for quite some time, because AI is, like you said, it has become your friend, right? In fact, I was telling someone that I foresee a future where now the more the AI understands you, in future they'll now, AI is not only the chatbots. This is what you're referring to as a chatbot, but robotics are still AI. There's still other AI use cases out there. So I'm looking at this in future being the ability to say, now can I buy a robot which is humanoid, and then I download this memory I've created and install it in this thing. Then it becomes another me that I chill around in the house with, asking questions, talking to. That's where I think the world.
Dennis, I'm
And
gonna get your
in a
friend. I'm gonna
huge way.
get your friend, Dennis. Derek. Sorry, Derek. I'm gonna get your friend. You seem like you need a friend. But no, but I've seen those futuristic kind of movies, right? I think was it iRobot, the movie for Will
Yes,
Smith,
they're coming.
where everybody
These
has
things
their
are
own
coming.
humanoid at home, and they just, they talk, they do whatever they do, and so so I know what you're saying exactly, right?
Yes.
That is a reality that's coming. Okay, let's move to the second question. Only on question number one. Question number two: what's one underrated AI breakthrough you think we should all be knowing and talking about?
I think what happened in the last 2 weeks, I think that is a big breakthrough for a company like Nvidia coming up and writing a whole, I think it was a 5-page letter in support of open source. That is a big breakthrough that needs to be highlighted a bit more, because open source now means, everyone can have access to things that have used billions of dollars and thousands of GPU hours to train. And you see, the more you look at what other people have done, the more you're able to build maybe a lighter version of it. So by, let's say, AI engineers here, AI labs here interact with these open source models, the more they will start to find interesting ways of making large language models, but the African way, cheaper, affordable, and easy to deploy. So I think open source models are a big breakthrough, and NVIDIA supporting that means that's where the industry is going. So finally, for Africa and Kenya, we don't need to. We can use what they have built and just improve on it at half and a fraction of the
Okay.
cost.
I'm going to ask you a cheeky question, right? I'm sure you saw these where I think it was someone in the US government who said that Kimi 3, which I hear now is performing just as well as Claude and,
Yes. Yes.
OpenAI models and so forth. They say that, they've just taken the model and they've just literally copy pasted it. I'm using English to explain, right? And now they're selling that. And of course, there's a question of what did they do in the first place to train their model? I don't know. And I guess the question for you here is, I mean, of course, we are moving towards this open models or open source
Open
models
weights.
and so forth. But what does that mean in terms of, data privacy, data ownership, about IP in the first place? Or do we just close our eyes and say, the scene already started, let's just keep moving?
But the truth is, this will happen anyway. If you remember, we are in they say they call it the fourth industrial revolution, which is just AI data. But there was the last decades, and you could see what China made a lot of things mainstream by just looking at what Americans are doing, and even they were not hiding. They would say Alibaba is Amazon of China. Taobao is Google of China. WeChat is Facebook of China. So, that's what's going to happen. The engineers are going to look at this model and say, oh, I can recreate that, but the African way, which means low cost, less infrastructure. And the truth is, honestly, these markets have not developed enough to be very strict on data privacy. We give away a lot of our data, right? So it's
Fair enough.
it's a lie if we say we are so serious about data privacy and all that. All we need is
Yeah.
affordable ways that at least have a certain value of what we create in the AI value chain actually benefiting, our own companies, our own markets, our own governments, instead of just shipping everything by paying dollars to these global AI companies. It's going to happen.
Fair enough. Fair enough. I like the question because there's also the other angle that they're not building for us, right? So we can't
Yeah,
keep waiting until they finally
yeah.
remember that we need contextualized models to address some of the challenges we have. Last question: if you had unlimited AI resources, what would you solve?
AI infrastructure. So AI infrastructure is that conversation of when everyone is mining gold, you sell them the shovels because they'll always need the shovels. So everyone who's building AI, they're always going to need infrastructure. So
Nice.
infrastructure. It's the way to retain capital, because if we have our own capital flowing into infrastructure, it means the GPU hours that are consumed training this actually benefit, let's say, an institutional investor, local bank, local capital, venture capital. The capital remains internally, right? So, and everything, like I said, if you remember the 5-layered cake, everything just comes after solving the first 3: power, chips, infrastructure, then models and
Wow.
applications, the software part.
I think that's a very good closing note.
Yes.
This has been super awesome. I think today we've delved, in an area of AI that people don't talk about. Everybody just wants to speak about, chatbots and the models. Nobody want to go, below the hood and ask what actually makes AI work. And I think you've
Yes.
really helped us to understand that really well. I'm just going to give you maybe 30 seconds if you have any closing remarks before we wrap up today's episode.
Yeah, I would say, yeah, AI infrastructure, digital infrastructure is the new digital real estate. The truth is, evolving nature of the investment space, the younger people, the millennials and Gen Zs are going to want to invest where they spend most of their time, and that is their phone.
Okay. And I know we'll get your contacts. We'll share those out. Anyone who's interested to sort of like get in touch with you, if they want to make investments in AI infrastructure, if they want to learn more about the topic, if they want to invest in the company, we'll make sure that they can get to you in this case. Thank you very much for joining us. We really appreciate. So thank you for joining us. That's been an awesome conversation on AI infrastructure with Derrick, who I think has done an amazing job to help us to understand just how AI works and what happens behind the hood. And I hope that the next conversation that we have with him now will be after he's localized some models here, and we can sort of like figure out for some corporates what can be done and so forth. So this has been your host, Stephen Gugu from China AI, where we make AI conversations practical, one conversation at a time, with conversations brewed in Africa. Thank you, and see you in the next episode.